Thank you for coming, everyone, and it's a great opportunity. Thank you for this opportunity. So let me do this. Let me temporarily, if you don't mind, hide behind my icon, but I will resurface toward the end for Q&A, just to avoid some distraction. So let me start by explaining where I'm coming from, because everyone's story is different and mine may be unusual too, because I spent most of my life in academia doing work mostly in analytic philosophy and philosophy of science. But I've been teaching a lot of logic and philosophy of language lately and have always been fascinated with languages, both formal and natural languages. So this prompted me to learn at some point some linguistics and also learn about translation and get in touch with these two very different communities, HT and MT. I discovered, among other things, that human translators are professionals who pride themselves on the quality of their work with the standards set and maintained by professional associations such as yours. And that producing a good translation is a difficult, fascinating, and intensely human endeavor, as rich as any other area of human creativity, in the words of two prominent computer scientists. It's also a valuable service, of course, but we know that for 70 years now, human translation has been facing competition from machine translation, whose explicit primary goal from the get-go has been to make human translators irrelevant by rendering their services unnecessary. So here's a very striking fact. There is now a whole new generation that grew up thinking of translation not as a matter of professional service, but as a matter of pressing a button. Indeed, finding the button may be the most difficult part of it. And in general, it may be natural today for an average consumer of translation to think of it as best as a commodity, not a service. Or maybe at a slightly more enlightened level, think of it as a computational task that is available at a mouse click. So it's sort of like solving a system of linear equations. So why would anyone pay for that? That's a natural question that arises for like in the minds of many Gen Z folks, obviously. Now, of course, we know that the goal of driving human translators out of business has not been accomplished so far, but it continues to fuel the rapid development of MT, which has gone through several stages. So I'll just fly very fast through these stages just to put some facts on the table and then, use it as a background. So here they are. There were two major revolutions in this process. The first was the transition from rule-based systems to statistical MT, which had to do with these developments. Just to check, is everyone still seeing this screen with the moving images? Yeah, okay, great. So the key paradigm change here was to model new translations after the existing ones by leveraging a massive number of parallel sentences in multiple languages. The second transition, which is much more recent, from statistical to neural, has to do with the dramatic expansion of compute power and the success of deep learning methods in artificial intelligence. This revolution, which is ongoing actually, is of course rapidly transforming the field, and it's transforming our everyday lives, even as we speak. It's interesting, I find it interesting that all the major achievements, all the landmark achievements in neural machine translation were made in a space of just 3 years. This includes the original sequence-to-sequence model, and I'll skip my illustration here, and then the attention mechanism, and of course the transformer. So all of that was made actually in 2 years. But I would also add these two pieces. There are these word segmentation methods, such as byte pair encoding and sentence piece, and some others. I would add them to the list of landmark achievements. I think everyone is going to be part of any future history of the field, no matter what may happen next. So, and by the way, this is how the word segmentation algorithms may split the word periodontists in the plural and map it to parodontist. So you may see that it kind of cuts across the internal morpheme boundaries, but turns out to be incredibly efficient. So that's interesting, isn't it? So at this point, transformer models remain state of the art in MT, and they continue to beat all the performance records. Nobody really knows what's coming up next, and when the next major breakthrough may happen, but the field is developing at rocket speed. So, I mean, sorry for moving so fast through this, but this is just a sort of a useful background, hopefully, to what I'm going to talk about next. But it's obvious that MT has come a long way, and its quality has become quite stunning, even scary. For example, it does terrific job on convoluted sentences like this one with center embedding. And these long distance dependencies, making the correct gender and other inflectional choices at across these very long distances. So I know that you probably have to take my word for it, but this is how it works into Russian. The book is feminine in Russian, and it requires agreement with the verb right there. But the agreement in gender, right? But the agreement happens across this long distance. You can actually make it longer, and it still works. And it includes a lot of nouns like brother, actor, and boy, which are all masculine, right? But the system gets it right. And although it's easy to take it for granted nowadays, I think it's really fascinating. It's quite stunning. But the quality also remains very uneven, doesn't it? So the last time I checked, neither Google nor DeepL could handle the kick the bucket thing. And moreover, it's quite fragile. A small ungrammatical change, basically just a typo, results in a relatively fluent sentence, which has little to do with the source, actually nothing to do with the source. So we kind of need to be very careful because the output is very fluent nowadays, but sometimes it may be a wrong output, right? But in any case, my goal is not to make fun of that. Actually, it's quite the opposite. As I said, I find the quality of MT quite stunning. And I'm fascinated with the progress that was made in the last few years. So despite all the hype, so someone came up with this interesting curve that illustrates the cycles of hype. But there's also this reality line, the blue line, which kind of looks and feels very real. And it's putting a lot of pressure on human translators. It keeps raising the bar, even as we speak. So if we want our work to have commercial value, we need to do a lot better than Google Translate and even DeepL. So that brings me to the real topic of my talk, which is domain adaptation. But I should say that this success encourages us to rethink more generally the entire relationship between HT and MT. It's true that historically it's been uneasy and complicated, but an increasing number of stakeholders are now coming to view it as synergistic. So to make use of this synergy or symbiosis. Translators as well as LSPs are now, of course, using MT suggestions alongside TM matches, translation memory matches, in their workflow, especially since most CAT tools now have plugins for popular MT engines. Well, that means embracing post-editing in one form of the other, and it has become really the default mode, the default work mode for many. So that brings me to domain adaptation. The problem of domain adaptation arises because general purpose MT systems are trained virtually on everything they can possibly find, scrape, clean, and align from the huge amount of multilingual data. But most of professional human translation is specialized. That's what gives it a real value. So to simplify, we know, don't we, that we need to translate conductor in this passage as music conductor and not electric conductor or railcar conductor. And we know that to address your CEO, you need to say, "Good morning, sir," rather than "What's up, dude?" And that we know that bat can mean different things depending on whether it occurs in a baseball commentary versus a wildlife report. So that's how languages work, right? They cut across each other in this semantic space. But generic MT systems do not always know it. But the desire to automate everything is unstoppable, of course. It's safe to assume that everyone capable of doing it, and that includes not just tech giants, but also custom MT providers and LSPs, big or small. So everyone is actively working on fine-tuning MT systems to particular areas, such as oil and gas, or clinical trials, or pharmaceuticals. So to get back to my example, running this passage through DeepL gives a much better result. And it may be due to domain adaptation, which in this case may boil down to something as simple as taking into account a context which is longer than a sentence, right? That's all you need. So it should be clear that learning domain-specific terminology and learning from good specialized translation memories is very important. And everyone in the language technology industry is keenly aware of it. Well, what about freelancers? They are quite often in possession of golden resources, golden bilingual resources, which result from years of painstaking work and which continue to generate steady revenue. So can human translators use these resources in their workflow to improve MT output? Yes, it's becoming increasingly possible, and there are several options for that. So I'll start by mentioning, linking, and setting aside those options that are more advanced, but probably not ideal for individual translators, not at this point anyway. But if you are using any of those, I'd love to know it. Yeah, let me know. I'd love to talk more about it. But the more advanced options include these tools and platforms developed by Google and Microsoft, and I'm pretty sure others, that allow customers, primarily enterprises, to train their own domain and language specific neural translation models and use them in production, more or less in this way. Yeah. So, for example, Google offers AutoML translation, which is part of their AutoML platform, and Microsoft offers custom translator as part of their Azure cognitive services. And these are just two examples. On the other side of the spectrum, there are startups such as Intento and small companies like GT4T, which offer access to multiple MT engines. So here's the whole laundry list of the engines that Intento gives access to. I actually wasn't aware of most of this until I looked it up. There's access to multiple languages, and sometimes the possibility of choosing the best suggestion for a given segment, presumably based on some interesting similarity metrics and other MT and more generally machine learning methods. And sometimes the whole process can be integrated into CAT tools. So there are nice reviews of these tools by Jost Zeitche and others. I'll just, I will refer you to this if you're interested, but I'm not going to say anything more about these more advanced options. Instead, I want to focus on two usual suspects, which everyone is now talking about, and share my experience with them. I will also try to speculate a little on what may happen behind the scenes when you use these tools. And in most cases, it's just a guess, because unlike academic MT research, which is driven by the spirit of open sourcing and sharing the data and all of that, industrial applications are, of course, shrouded in a veil of secrecy, even when we can make an educated guess. So please don't quote me on how these things work, because in the end, I don't know. But with that in mind, my plan is to go over these two tools because they are popular, currently popular, and they're easy to use and integrate into the CAT process. And they also demonstrate somewhat different ways in which domain adaptation and fine-tuning can work. I should add that my selection of these tools, of course, is quite subjective. I should probably mention that I'm not paid by them to promote their products. I just happen to be familiar with them. And your experience may be different. It all depends on your language pair and domain, because there are literally dozens of powerful MT systems on the market now. Okay, so starting with DeepL. It has become the engine of choice for many translators and LSPs. And the main reasons I'm hearing are excellent suggestions for many popular language pairs, excellent translation suggestions. And also, the system offers alternative translations for segments that are like usefully short, not for very long segments. And there are additional cool features that I mean to go over. I should say that all of that probably has to do with the data and not the algorithms. And I'm saying probably because it's a guess, but DeepL's data, of course, has excellent pedigree in Lingui, its mother company, which is famous for highly contextualized translations of phrases between 20+ languages. This grounding in context is, of course, key to training a good neural MT model. On the other hand, when it comes to algorithms, the differences between the major providers of MT may be insubstantial. So as I said, everyone is now using the basic transformer architecture, plus minus different hyperparameter settings and relatively small pipeline modifications. But that's sort of the mainstream nowadays. Okay, so DeepL currently supports 20-something languages, 25, I think, and all of them except Brazilian Portuguese and simplified Chinese are European. At this point, the list unfortunately doesn't include Hebrew, doesn't include any other Asian languages. But they are in the process of adding more languages. It's not so clear when it will happen because, of course, it requires training new models and it kind of grows exponentially with the addition of languages. But they are working on it as far as I know. So the tool, of course, works as a web interface, which kind of looks the same almost in any case. But you can also download a Windows version or an iOS version, which basically reproduces this interface, but not as a web interface, but rather within an app that is running on your computer. But of course, it's running in online mode. So it's talking to the internet still. So there are a few additional features in DeepL that I do want to go over. One of them is tone setting between formal and informal, as I illustrate here for German, which affects basically the choice of pronouns, sie versus du, and immediately surrounding words. This currently works for 8 or 9 languages where it's needed, not for English, not needed there. The other feature is glossary upload, which is supposed to enforce correct terminology translation. So I should mention perhaps that these examples are, I cooked them up. Actually, they're for demo purposes. And I created them using an existing corpus of medical translations and then made some slight changes here and there just to illustrate some interesting phenomena. So you should definitely not use this as any kind of medical advice, not by any means. Okay. So just what happens here, it may not be entirely clear, is that when you turn the glossary option on, and if you upload the glossary, then the translation of some terms changes as it should. So in this case, it changes from cardiac muscle to myocard, a more technical term, which presumably is in the glossary. Okay. So I'm kind of interested in these questions. I want to know what goes on behind the scenes. That actually drives my interest in the field. So I want to look a bit under the hood. So with DeepL, I did a lot of homework. So I searched for any relevant publications, didn't find any, and I wrote to the DeepL folks asking them for the details of these algorithms. Well, they replied very fast by saying, hey, Yuri, you seem to be a good guy, but we're not going to tell you. Sorry. So the only thing I can do is speculate, and I may be wrong in my speculation, but I can think of 2 ways in which both tone adjustment and glossary correction could be done. It could be done at pre or post processing, where the system will translate as before, excuse me, in a generic way. So it will translate music conductor as electric conductor, but then the output will be corrected by searching and replacing glossary items, essentially. This is not entirely straightforward and may involve some statistical alignment or smart use of lexical resources, which Lingua, of course, has in abundance. But then it's not exactly rocket science either. But it could also be done in a more interesting way by incorporating glossaries into the decoding process. Well, if that's what it is, and if anyone knows any details, I'd love to know them too. Yeah. I should add that unfortunately, glossary support is very limited currently. It's only available for these 6 language pairs. But they're adding more, so there will be more. We should probably keep looking. Finally, I wanted to mention dictionaries. and on-the-fly adjustment of translation built into DeepL. So essentially, you can hover over any word in the target window to see its alternative translations. And you can make any other changes in the translation, and the system will take it from there, right? So it will autocomplete the whole segment. The dictionaries, of course, come from DeepL's extensive resources, and the adjustment on the fly is probably, again, I'm saying probably, implemented by means of prefix constraint decoding, which is sort of similar to what happens in other forms of interactive translation prediction, which is becoming very popular. So it was first used in MateCat, and then in Lilt, and currently it may be used in any number of other systems. Okay, so let's see how we're doing. I think, yeah, we're doing well time-wise. So this may be a good juncture to talk a bit about how to integrate MT engines into the CAT process. And many of you probably already know it, but just in case you don't, it's pretty straightforward. MemoQ, for example, offers 24 pre-configured plugins for various popular systems, including Intento, by the way. So to activate any of them, you simply need to input the API key into the MT settings window. So click on settings, it opens this window, and then copy and paste the API. But there is a caveat, right? You need a paid subscription to the service. That's where you get the API from. How much? Well, in this case, it's about $25 per month. And if you want DeepL, you should probably subscribe to the advanced plan, because the starter doesn't integrate with CAT tools. And they will prefer to bill you for the whole year, of course, but they will give you a discount. So this is what it comes down to. Is it worth it? Well, that depends on your situation, on your language pair and domain and your workflow. And in deciding, also bear in mind that subscription buys you confidentiality, which is to say that the source sentences you transmit to the engine, the translations you receive, and anything else you upload, including glossaries and memories, will only be stored temporarily in RAM, basically. So in particular, it will not be used for training the engine or any other purposes of that sort. Now, can you be like 100% sure of that? So suppose you want to upload a glossary with a lot of product names, maybe personal names. Is it safe? Well, I think there's no reason to distrust these statements. There was an interesting discussion of this issue, actually. And I should add that, I feel very comfortable doing that. I think it's as safe as anything could be, like nowadays. It's not always been that way. So if we're all back a few years, maybe 3 or 4 years, some of these systems were kind of using the data that the users upload for training. But some of them made a smart decision to stop doing that. And that's where all these statements are coming from. But of course, you always need to read the fine print, and I'm not a lawyer and all that, and so on. The flip side, in any case, is that no guarantees are given to anyone who is using free translation services, which means that if you don't have a subscription, or if you don't log into the web interface as a user, all bets are off. Okay, so once you have plugins activated in MemoQ or Trados or another cat tool, you can use it to generate translation suggestions as you go for those segments for which there is no good TM match. Or if you prefer, you can pre-translate the entire document or several documents by using such settings. In MemoQ, you can also benefit from MT-driven match patch. Basically, it's a fuzzy match repair algorithm. Usually it's used with term bases. But if a fuzzy match cannot be repaired with term bases, then MemoQ will query your chosen MT engine for the translation of the non-matching string. And other cat tools may be capable of doing the same now. Yeah, I'm pretty sure. All right, so obviously all of that is convenient and efficient, but there are some trade-offs when it comes to using MT engines within cat tools versus outside them. So for example, if you use DeepL in MemoQ, you cannot benefit from the additional cool features I just mentioned. The system will simply give you what it takes to be the single best translation with no alternatives, no dictionary lookup, and no online adaptation to your corrections. Actually, there may be online adaptation, but no alternatives. And so you just take it from there and post-edit from start to finish. That's the only thing you can do inside. So if you really want to use the extras, you probably need to open the web interface or the desktop app in parallel, hopefully on a separate screen, and then use it when needed. And if you do that, again, don't forget to log in if you want your data to remain confidential. All right, so I want to turn to ModernMT, which was also born in 2017. So it's another success story and a fairly recent one, but this time resulting from a very fruitful symbiosis of academic MT research with important commercial developments. I should say that it's not entirely open anymore, unfortunately, but it is a product of collaboration among several entities. One of them is Translated, which I think still holds a majority of the shares in ModernMT. And of course, it's famous for this My Memory project and also for MadeCat, which is a predecessor of ModernMT. So Translated is one source of this project. Taos is another, but then there's also the University of Trento and the University of Edinburgh and the European Commission and Fondazione Bruno Kessler. What makes ModernMT different from DeepL is its advertised ability to learn from several things, and that includes translation memories and your corrections, and sometimes also the context of an entire document. And it does it, interestingly, in a way different from standard domain adaptation. And it does it at a fraction of the computational cost, which means very fast and inexpensive. So standard domain adaptation is done essentially by repeatedly retraining the entire NMT model on additional parallel data. Let's say on your golden translation memory for, I don't know, pharmaceuticals with 10,000 or 50,000 units in it. And that's how it's done, for example, in Lilt and in Microsoft Custom Translator, or in OpusCat for that matter. ModernMT also makes use of your memories, but it starts by matching them to the context of the current open segment, which may include surrounding segments, and sometimes it includes more than that, up to the whole document. The system then retrieves several translation units from your memories or from a single memory that you designate for it. And it ranks them by similarity to the context vector, the current segment, essentially. Then it uses the information, so retrieved, to set dynamically the hyperparameters of the neural network to adapt a temporary copy of the very same stable base generic model to the current context. So the model remains the same essentially, and a copy is created only temporarily, and then it's discarded when the system goes to the next segment. So then the retrieved translation units are used to quickly fine-tune the model, more precisely the copy of the model, which then, of course, generates MT suggestions that are hopefully closer in terminology and style to the current context. And you may accept or post-edit the suggestion. The confirmed segment is added to the resource memory, but then the copy of the model is discarded and the system moves to the next segment. Or at least that's as much as I could glean from these 5. Yeah, all of that is my speculation, but I gleaned it from this old paper and also from a more recent patent application. But if you look at the dates, 2017, 2018, it was filed in 2018. That's like the eternity for neural machine translation. So I'm not sure how much of that still applies. I'm trying to like extract this information from the ModernMT folks, but no success so far. I'll keep trying. And if you know more, please let me know. So all of that sounds pretty cool. Does it work? Well, yes, I can report anecdotally that ModernMT suggestions are indeed informed by memories. I cannot really show a real life example, but I have my toy examples, which are coming from this corpus, the European Medicines Agency corpus, which is, by the way, available for you to use if you want in TMX or other formats on this website. So I discovered, for example, that after consuming my toy memory, ModernMT corrected its output by basically fronting this clause. So instead of saying treatment with the enzyme, blah, 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 it starts with this clause, which really comes from the end of the sentence. So that's kind of smart. No other MT engine did it. And the idea could only come from a project-specific translation memory. It also corrected this term with a more technical analog. All right, so I'm kind of coming to a close, but just a few more slides. So I wanted to mention that ModernMT has a much broader language coverage, about 50 languages, including, importantly, Arabic and Hebrew and Hindi and Irish and Vietnamese and a lot of others. So it's about 2,000 language directions. How much does it cost? $25 per month. Yeah. So I would say, based on my experience, ModernMT and DeepL nicely complement each other. So one of them gives better generic translation. I think DeepL does better on that score, but it cannot yet adapt to bilingual resources, translation memories and term bases. ModernMT does it a lot better. So they nicely complement each other. Is it possible to use both? Of course. You can actually add, let's say, basic Google Cloud as a baseline of sorts, activate all 3 in MemoQ, and hit the road. Furthermore, you can designate one engine for pre-translation, for example, Google, another one for match patch, DeepL, and keep ModernMT for online adaptation, right? So you can do all of that in MT settings. And when everything is said and done, you can see all three suggestions, right, in your translation results pane. Here they are. And you can see that they are like delightfully different, right? And there are, for the most part, I would say most often there are some differences, even in cases like this. So just looking at these three, I would say the first one is kind of awkward, right? A solution for infusion, the active substance of which doesn't sound right. So this one is better. This one may be the best. So the first one is from Google, I think. Second is DeepL, and the third one is ModernMT. So having all that in front of you is hugely helpful, isn't it? You can get the best of all worlds, essentially. Yeah, that's what I would recommend. All right. So that leaves out many other interesting tools, such as Microsoft Custom and Opus Cat, for that matter, and a lot more. So let me repeat that my selection was subjective, based on my own experience and information, and yours may be different. So I would say, try it. You are in the best position to evaluate the output of a fine-tuned model and compare it with other systems and decide whether it can be used in your work. All right. Thank you very much.
Yeah, thank you. This was fascinating. A lot to unpack. Okay, we have a bit of time. Any questions, comments? Anyone?
Is the where we have access to the slideshow? Because there are a lot of information that somehow I didn't write down in time.
Yeah, that's a great question. I should direct it to Uri. Yeah, I'm perfectly fine sending the slides.
Yes.
Yeah, I'll do it.
Thanks.
Let me see if I can open the chat. Yeah, just in case.
Yuri, which of these, apart from, does Opus Cat work with Russian and Hebrew, or, I mean, because the DeepL is quite limited in language combinations, but you said that ModernMT works with Hebrew. So which other ones work with Hebrew?
Oh, I would say lots of them. I haven't really checked, but definitely Google, both basic and advanced, and Microsoft. Yeah, I bet it.
Does Opus Cat work with Hebrew?
Well, that's an excellent question. I really don't know the answer. It really depends not so much on the like cat part of it, but on the Opus part, because that's where the models are stored when they are pre-trained. Yeah, I would need to check, but you can do it yourself if you just go to this open Opus MT resource. But I think it's better just to open Opus Cat if you have it and check if you can download the model for Hebrew. Sorry that I cannot answer right away.
Okay, if there are no more questions or comments or anything, I think we'll go to a break. And next talk is at 7 p.m. That's going to be the.
All right. Thanks very much, everyone, for coming.
Okay.
Really
Thank you, Yuri.
appreciate
It was a
this.
great talk.